you very much. Hello, everyone. My name's Lou Delatorre. I'm a solutions architect with AWS. And as was mentioned, today we're going to be providing you a unique experience in that we're not only going to discuss what Amazon Elastic Compute Cloud means and what it can do for your Windows servers, but we're going to be providing you a demonstration as well of how you can launch your first EC2 instance running Windows Server on AWS. And via the demonstration, you're going to see how you can use Windows Amazon Machine Images to launch Amazon EC2 instances, how you can bootstrap your instances using PowerShell, as well as create key pairs for authentication, secure your network access to the EC2 instances with security groups, and attach elastic IPs to the EC2 instances. And at the end of the demonstration, you'll see how you can easily deploy a simple web server and view the metadata of your Amazon EC2 instance via the internet. So as was mentioned, we'll provide you with the instructions at the end of the demo so you can also complete that lab on your own. So let's go ahead and get started with the Amazon Elastic Compute Cloud for Microsoft Windows Server Hands-on Lab webinar. Now, when you think about traditional IT, it can tend to be very slow, expensive, and difficult at times. There are different challenges that you can face with traditional IT deployment and infrastructure. Usually, if you've been working in IT for many years, you've probably experienced that it can take weeks or even months just to acquire and set up infrastructure. Well, Amazon EC2 makes cloud computing affordable, easy, and scalable. Now, EC2 stands for Elastic Compute Cloud, which is our core service for infrastructure as a service on the cloud, on the AWS Cloud Platform. Why are people migrating to the cloud? Well, there are many different reasons why, but I'd like to highlight just a few key reasons why people are flocking to the cloud. One reason is they're converting their capital expenses to OpEx or variable expenses. Many customers find that they get lower OpEx on AWS than by doing it themselves. Also, agility, elasticity, better use of resources, and being able to scale globally immediately are other reasons why many of our customers are migrating their resources and their data centers to the cloud. Now, AWS offers over 90 global services. As you can see in this screen here, there are many different services that are offered, including compute, storage, database, networking, security, analytics, and application services, as well as deployment, management, and mobile services that help you move faster, also help you to lower your IT costs and scale your applications. And these are best of breed services with open standards and Microsoft interoperability. Most importantly, customers have many choices without lock-in. So you can choose the services you want to use, for how long you want to use them, and how you want to use them. With Amazon EC2, you can choose between different configurations to meet your computing needs, whether you need to optimize for CPU, for memory, storage, or networking. You have the options to select the instance types that meet your workloads demands. EC2 provides you with Amazon Machine Images, or AMIs, that are pre-configured with Windows Server, and we'll provide an example of that during the demonstration. You can also, if you prefer, build and import your own servers so that you have your own golden images that you deploy any net new Windows servers on EC2. We work with Microsoft to bring you all supported versions of Windows Server on AWS. Now, AWS for Windows uses a security in layers approach. And what that means is you can use a combination of Amazon Virtual Private Cloud, which is like your own your own secure, isolated, logical data center in the cloud, and also provide you with network access control lists, security groups, host-based firewalls, and intrusion detection systems so that you can create a layered solution for network security. At AWS, we have a shared responsibility model, which means that AWS is responsible for the security of the cloud, and you, the customer, are responsible for the security in the cloud, meaning your operating systems and your applications. You can isolate your environment by creating private subnets with Amazon VPC. You can use a traditional VPN or an encrypted low latency dedicated connection to your data center with the AWS Direct Connect service. You can leverage the AWS Identity and Access Management service, which integrates with Active Directory, thus providing you with fine-grained access control to your AWS resources. And also, AWS CloudTrail logs your API call history, showing you who has requested access to data and compute instances, when they requested it, and the response elements returned by AWS. And that allows you to maintain and meet your audit and compliance requirements within AWS. AWS also offers a highly reliable environment where Windows instances can be predictably provisioned. We have a service level agreement of 99.95% availability for each region. And each region has at least 2 physically isolated facilities known as availability zones. So you can keep your applications highly available. Now, AWS currently features 43 availability zones in 16 regions, with more being added all of the time. This gives you reassurance that your mission-critical data and applications will be available even in the face of natural disasters or other rare events. AWS also provides a service health dashboard that shows the status of each of our services in real time. So we're fully transparent, and we show you how our services are performing. The AWS Cloud is a high-performance IT environment. You can automate complex tasks without sacrificing any visibility or monitoring that you need to be sure that your workloads are up and secure. Our auto-scaling is also very flexible, so you can scale your workloads manually, by schedule, by policy, or by auto rebalance. And you can make an API call or just use a command line interface to instantly launch or terminate instances so that you can ensure applications are being balanced across multiple availability zones. Automation tools also allow you to spend less time on routine tasks and more time on your business focus. AWS CloudFormation, which is our infrastructure as code service offering, gives you an easy way to create and manage your AWS resources, provisioning and updating them in a consistent manner. Monitoring and management tools are built into Amazon EC2 and also integrate with many of the Microsoft solutions that you may be using today, whether it's Microsoft System Center, or even if you're a VMware shop with vSphere, we offer VMware vCenter add-ins so that you can easily import your images and also monitor your applications. Now, the performance wouldn't mean much unless the platform was familiar. So that's why we designed Amazon EC2 for Windows to be a familiar administrative experience for your Windows workloads. So AWS is compatible with many Windows applications, such as SharePoint, SQL Server, I mentioned System Center, and VMware vCenter. The VM import service allows you to easily import your virtual machines or your virtual machine images from your existing environment into AWS. And then you can even export them back to your on-premises environment if you chose to do so. Windows Server and SQL Server licenses can also be purchased hourly from AWS via Amazon Machine Images. And with dedicated instances, you can provision servers dedicated to running your applications. Combined with AWS VPN or AWS Direct Connect, dedicated instances can act as an extension of your data center, allowing you to take advantage of more flexible software licensing terms. So on AWS, you have access to the same tools as traditional on-premises environments. For example, if you're running SQL Server on-prem and you migrate SQL to AWS, you can still continue using SQL Server Management Studio. If you develop .NET using Visual Studio for your .NET applications on-prem, you can continue using Visual Studio for your .NET applications on AWS. And we even have plugins for Visual Studio that allow you to develop and deploy your code directly onto our services within AWS, such as Elastic Beanstalk. And also, if you're using Windows PowerShell, which most, if not all, Windows administrators these days are using to manage their Windows environments, you can certainly continue to use Windows PowerShell to manage not only your applications that reside within AWS, but also your AWS resources within AWS. AWS for Windows helps you benefit from economies of scale. Now you can consume your IT elastically, so it scales with your needs. You take advantage of pay-as-you-go pricing models, and you no longer have to commit to long-term service commitments. With traditional on-premises approaches, you need to plan for and invest in infrastructure to handle what you predict your peak needs will be in the future. Oftentimes, you have to plan for this a year ahead. And then you have to maintain that whole infrastructure regardless of how much you actually use. With AWS, you can scale up or down any time, ensuring that you only use the resources that your application requires at that time. AWS offers ways to move your workloads, your Windows workloads, to the cloud without incurring additional Microsoft software licensing fees. With Microsoft License Mobility through Software Assurance, your eligible software licenses can be deployed on AWS. And if you don't have software assurance, you can leverage our dedicated hosts or dedicated instances to bring your existing Microsoft licenses to AWS. Now, AWS has established a broad ecosystem of tens of thousands of partners who specialize in technology and consulting services that you can definitely take advantage of. You can use our Amazon Partner Network to look up the right partner for your business and needs and find a product or a service that will help you run on AWS. Now this slide here I notice is a little dated. We now offer more than 90 services on AWS, not 60. So just further demonstrating the extensiveness of our platform on AWS. Also, it's important to note that AWS technical certifications are available for solutions architects, developers, and SysOps administrators like yourselves. So certifications can help you gain credibility for your AWS experience. So certainly would encourage you to look into that as well. AWS offers services that can run virtually every enterprise application that you can think of. And there are, as I mentioned, over 90 different services. We have over 40 different instance types and numerous storage options for your Windows workloads. Just as an example, the Amazon Elastic Block Store service, or EBS, is a service that allows you to attach logical volumes to your Windows instances. If you need to run I/O-intensive workloads such as SQL Server, you can get provisioned IOPS volumes with performance up to 48,000 IOPS and single-digit millisecond latencies per volume. And if you needed to go above the 48,000 IOPS, you can certainly stripe those as well and achieve higher IOPS for those higher performant workloads. Now this slide here shows the diversity of Windows workloads that you can run on AWS, including Active Directory, SQL Server, SharePoint, and Exchange Server. We have many different reference architectures on our website that you can look at for these different types of workloads that depict and describe the best practices for deploying those to ensure that you have highly available deployments of those solutions on AWS. With our core services such as CloudFormation, Virtual Private Cloud, and Direct Connect, it's just like running Windows workloads in your own data center. CloudFormation, along with some of the quick starts that we've created on our website, allows you to spin up a whole SharePoint farm in minutes, which is fantastic for dev and tests and demos. And what's even more interesting is that you can shut it down on weeknights, on weekends, automatically or with the click of a button, and automatically save on costs by shutting those down. So again, I would encourage you to take a look at our quick starts on our webpage for each of these different types of workloads. If you're planning on deploying those on AWS, we can help you deploy those in an automated fashion using the quick start in our CloudFormation service. This diagram depicts a simple VPC in AWS. So when you start looking at our reference architectures on AWS, you're going to notice a lot of similar patterns as far as what a VPC includes, different subnets, internet gateways, for example. And you see in this, so it's kind of good to review this just to give you some familiarity on what that's going to look like, so you understand those diagrams as you start digging deeper into those reference architectures. But what you see here is a VPC, and at the top you have an internet gateway. Also on the right side you have a virtual private gateway that connects to the corporate network. Now it's important to point out that both of those are optional. So what that means is you can have a VPC without an internet gateway. So the only traffic in and out would be through your own corporate firewalls via that virtual private gateway. Route tables are really simple to set up in AWS. You can route traffic between public and private subnets in your VPC and to your corporate network or other Amazon Web Services such as S3 storage service. You can also use our Systems Manager EC2 Run Command feature to remotely execute tasks on your instances without needing to RDP into them. So for example, you can run PowerShell scripts against 1, 10, 100, 1,000 or more instances, domain join those instances or install software. And even more interestingly, you can do this with your on-premises servers. So the Systems Manager service allows you to not only manage your instances within AWS, but also your servers within your own data center or any other virtual machines that may be running in any other cloud provider.
Today's demo is going to lead you through the process of launching and configuring your first Microsoft Windows virtual machine in the Amazon cloud. You'll learn about using Windows Amazon machine images to launch Amazon EC2 instances, bootstrapping with PowerShell, creating key pairs for authentication, securing network access to Amazon EC2 instances with security groups, and attaching elastic IP addresses to your Amazon EC2 instance, thus providing static internet addresses. By the end of this demo, you will see how you can deploy a simple web server and view the metadata of your Amazon EC2 instance. So let's go ahead and get started with our demo. So the first step is going to be to launch your AWS console. So you're going to want to log into your console, and then you're going to want to select EC2 and go to the EC2 dashboard. Now within the EC2 dashboard, you're going to see the option here to launch an instance. So that's going to be the first step. So click on Launch Instance. And in the first step, you're going to have several operating systems to choose from. And you're going to want to select the Microsoft Windows Server image or ARMI. So here we have Microsoft Windows Server 2016 base, We'll go ahead and select that, and that will default to the T2.micro. Now you have the option of selecting different instance types, instance families you can choose from depending on the resources that are going to be required for your server. But we'll go ahead and take advantage of the micro instance type, which is one of the smaller instances and lower cost options, which is automatically selected for you. And it's also one of our instances that's in the free tier. So go ahead and select that and then click on Next, Configure Instance Details. On the Configure Instance Details page, you're going to want to accept the defaults here and expand the advanced details below. Now, in the advanced details section, we're going to enter an initialization script in the user data text box, and we're going to select as text. Now, this is so that you can run some post-script operations on your instance once it's created. So it's kind of like bootstrapping your instance. So we'll go ahead and add some PowerShell code there, which I already have created. It's PowerShell command that's actually going to install the web server Windows feature into our EC2 instance so that we don't have to manually add that feature using Server Manager. We can just bootstrap that. So you can do this. You can just think of many of the other things that you can bootstrap your Windows EC2 instance with as well that may be required for any particular workload. So we'll go ahead and paste our PowerShell command into the user data. And again, this PowerShell command will automatically install IIS on this particular instance. So go ahead and click Next, Add Storage. And we'll accept the defaults here. So we'll go ahead and click on Next so that we can add tags. And in the value box, we're going to want to select Add Tag and add a key name. We can give this key name the name of name. And the value will be website. So essentially, we're naming our instance here website. And you can add additional tags if you'd like. For example, if you had any cost centers, you can create another tag with a key value, a key of cost center and a value of whatever that cost center number was, or an environment. Again, a key environment with a value of development, production, or staging. So you can just add whatever tags may be necessary for the particular instance. So click on Next. Configure security groups. Now on the Configure Security Group page, we're going to click the option to create a new security group. So it's already selected for us, create a new security group. We can name this whatever we'd like. I'll just call this a website security group. And I'll leave the description, just change the name to website security group created on this date, so we can so we're aware of when this was created and what the purpose of the security group was. You'll notice that since this was a Windows instance, it automatically added the RDP port, port 3389, which would be required to be able to remotely access this Windows instance. Now, there's a warning below saying that the source IP, which basically the source means anyone can remotely connect to our instance. However, they'll still require their username and password, but still it's accessible to everyone, so it's given us a warning. Typically in a production environment, you would want to secure this to maybe a range of IP addresses, maybe your specific IP, or from a range of IPs that are associated maybe with your on-premises network. So if you had a VPN, only your users in your on-premises network could access this instance remotely. But since this is a demo and It's only for testing purposes. We'll go ahead and leave it as is for now. And then we'll click Add Rule. So we can add multiple rules here in the security group and open up whatever ports we want to open. Since this will be a website or web server, we're going to go ahead and add HTTP as well as HTTPS. So that's going to allow us to access the website on this web server. So we'll go ahead and click on Review and Launch. This will take us to the review page where it'll show us all the options we selected. And then we'll go ahead and click on Launch. When you click on Launch, it's going to ask you to select a key pair or create a new key pair. And key pairs are used so that you can gain access to the password that's been created for your particular Windows instance. So this would be the administrator password. So you'll need this key pair to be able to decrypt and obtain the password so that you can log into this Windows EC2 instance. So I already have a key pair created and selected, and I acknowledge that I have access to the key pair. So I'll go ahead and click Launch Instances. So our instance is now in the process of being created. If we want to monitor the status of our instance as it's being created, we can click on this little View Instances button, which will take us to our EC2 Instances page. And you'll notice here that our website server is being created. It's currently in an instance state of running. However, the status checks indicate that it's still initializing. So that means it needs to go through 2 status checks and give us a green light or a thumbs up to go ahead and proceed by logging into the EC2 instance. So that'll take a minute or so, and then we'll be able to log in. Okay, it looks like our website server is ready. It is in the running state, and it has also completed 2 out of 2 status checks successfully. So it looks good. So now we're going to want to connect to our instance. To do that, at the very top, we can select Connect. And in the Connect to Your Instance page, we can first download our remote desktop file, which has all the configuration information regarding that instance, including its public IP address, saved in that file so that we can RDP to it. But we'll also need the administrator password. So to get that, we'll click on Get Password. Then we'll select Choose File and ECS Ohio Key Pair, which is where my instance happens to be and which is the key pair name I happen to give it. So with that key pair selected, we'll select Decrypt Password. And as you can see here, our administrator password is provided to us so that we can copy this password. So I'll Control-C that. I'll highlight it and Control-C it so I can copy it. And with that password, I'll go ahead and click on the RDP file, which will connect me to my instance. And here, I'll Control-V or paste the password that I had just copied, which is going to allow me to log in to my EC2 instance. So I'm logging in as administrator. This is running Windows Server 2016. And if you recall, we bootstrapped the installation of IIS onto this instance. So let's go ahead and confirm that IIS is indeed installed and available on this instance by launching Server Manager. So we're going to go ahead and launch Server Manager and just confirm that IIS has been installed. So once Server Manager launches, on the left-hand navigation bar, we should see IIS. Now, sometimes it takes a few minutes after the instance has been created for IIS to be installed. So we'll go ahead and click on the local server and give it a minute or so for IIS to complete its installation. So currently we have a public IP, but again, it's not a permanent public IP address. So in a few minutes, we'll go ahead and give it a permanent IP address, and we'll demonstrate how you can do that. So as you can see on the left-hand pane here, IIS is installed. So our bootstrapping worked successfully. So I'll go ahead and click on IIS, and then I'll go ahead and right-click on the server name. That appears then, and so we should see IIS here below in the menu. So we have Internet Information Services, so we'll go ahead and click on that, and we'll wait for IIS to launch there. So here's our IIS manager. I'll go ahead and expand that. Now if we click on the little arrow here on the left-hand side, we can expand IIS on this particular server. And if you're prompted with an invitation for Microsoft Web Platform, if you're, sometimes you may be prompted for that depending on the OS and version that you're running, just go ahead and click no if you're following along here. So let's go ahead and click the arrow next to sites and expand that. And then we will right click on default website, and we will select manage website and then browse to it. So we just want to confirm that we can browse to our IIS server. Give that a sec. So as we can see there, it's working to connect to our web page. And it looks like it's connecting here in the background. So I'll go ahead and bring the web page up to the front, and it says that it was able to connect. So we saw our IIS web server page here. So it seems to indicate that our IIS server is running successfully. So let's go back to our IIS manager, and we're going to open the directory where the web assets are located. So we can do that by, again, right-clicking on default website and selecting Explore. And in the Explorer page, we can right-click on IIS Start, the HTML document, and we'll right-click on that and open with Notepad. So we have our IIS page, IIS Start page, and here we're going to go ahead and expand this and then select everything that's in our IIS Start page just for a test. We're going to go ahead and select everything that's in there and delete it or erase it. And we're going to replace the content with some information that's going to essentially load the metadata on our instance. So I'm going to minimize this for a second, bring up my my HTML metadata information, and paste that back into our IIS Start HTML file. Go ahead and save this and close it out. So going back to our browser, and we'll bring up the IIS server homepage. Just go ahead and refresh that. And now you see that it loaded the metadata information that I pasted into the IIS start document. So if I click on instance metadata, it's going to give me information about this instance, such as the instance host name, instance availability zone, as well as the instance user data. So here we see the PowerShell script that we executed that installed the web server Windows feature for us. So we see that by clicking on the links, we're able to view our instance metadata and the data that was passed during launch. So now let's go back to our EC2 management console and go back to our website server in the EC2 management console. So what we're going to want to do here is copy the public DNS name for this particular instance. And we're going to enter that DNS name into the browser running outside of our RDP session. So I'll just go ahead and open up another browser. Again, this is not within the Windows server, but outside of it. I'm going to go ahead and connect to it remotely. So we see that we're able to successfully connect to this instance. HTTP traffic is being passed on, as well as HTTPS, due to the configuration we made for the security groups. So now what we're going to want to do is assign a fixed IP address. So AWS offers elastic IP addresses, which are actually NAT addresses that operate at a regional level. So that means that an elastic IP address can work across availability zones within a single region. So what we're going to do is assign an elastic IP to this instance that we created. So in the EC2 console navigation pane, if you look at the left-hand side there, we're going to scroll all the way down to Network and Security and select Elastic IPs. In Elastic IPs, we're going to click on the Allocate a New Address option, and then we're going to click on Allocate. So now a new Elastic IP address has been allocated for use within our account. So we're going to go ahead now and associate that address with the instance that we created. So we're associating it with the website server, and we're also selecting the private IP associated with that instance. So we'll click on Associate, and now our newly allocated Elastic IP address is associated with that web server. So with that, now we can actually navigate to that particular instance using the static IP or the fixed IP address that has been allocated to that instance. So if we go back to our instances, you'll see now that the public DNS name has been changed to reflect the public IP that's been allocated to this instance. So select copy, and we'll attempt to connect to it once again. So open up a new browser, paste in the updated public IP DNS server name, hit enter, and it takes us to our instance metadata page that's being hosted on that web server. So in conclusion, this demo has demonstrated how easily you can create a new Amazon EC2 server instance running Windows from an existing server template or Amazon machine image. I've also demonstrated how you can create a security group to restrict access to the server's resources by only making the ports that are required available, such as RDP, HTTP, and HTTPS. Showing you how easily you can launch the instance, access the instance, and also how easily you can associate an elastic IP address or a fixed IP address with your Amazon EC2 instance. So this concludes the demo. Thank you very much for your time and attention.